Alright, so talking about the falling down the incline, um, this is actually kind of a hybridization of Galileo's experiments with inertia. Talking about inclines, take objects going up and down, up and down. But it's a pretty common lab that you see in most colleges. The purpose of this experiment is to determine the acceleration of this car as it goes down this incline. Okay? The equipment you're going to need for this is a wooden block, a piece of tape, actually, here's a piece of tape, an incline, and a stopwatch. You're going to take the wooden block, you're going to slide it under one end of the incline, okay? And then, as you can see, this small incline that's being produced, you're going to take this, and you're going to let it roll down that incline, okay? But as it's doing that, you're going to be recording time. Okay, so you're going to put it at a position and you're going to record the amount of time that it takes for it to reach another position. Okay? So you're looking at the displacement. Cool? Alright, so let's go over the procedures in a little more detail. So you're going to take this card and you're going to start the card originally at 100 centimeters. Now this incline has 100, it goes up to 120, and it's got a built-in scale, so it's pretty easy to do. So just put it at 100, and then you're going to take your piece of tape and you're going to put it at the finish line. Now, my finish line is going to be at 10 centimeters. And the reason why I do it at 10 centimeters instead of the bottom of the incline is that from here all the way up the incline, my acceleration is constant. Okay? It's constantly accelerating. If I do it at the end of the track, my acceleration changes. So I want to make sure that I have a range in which my acceleration is constant. Cool? Okay? So, starting at 100, falling down to 90. Okay? Now another way in which we're going to reduce error is we're going to take multiple time measurements. So instead of just having one measurement for that distance, or displacement I should say, we'll have multiple. Okay? I would recommend that you're taking time measurements between 3 and 5 times per height. And what I mean by per height, well, after you're done with 100, why not do 90, and then 80, 70, 60, 50, 40, all the way down to 20, okay? So you're going to take from 90 to 10, so you're talking 9. We're going to have 9 different measurements, and for each one of those different measurements, we're going to have 5 different times, okay? So there's a lot of data that's being collected. Cool? So starting here, falling down to here, do that 5 times, then go down to 90, do it 5 times, go down to 80, do it 5 times, and do it, 70, 60, 50, 40. Cool? Now the other thing that you want to be, the other roundabout purpose of this lab is to do some real percent uncertainty and percent error with your experimentation. Okay? Because when we're going to do this, when we're collecting the data, we're actually going to be comparing time squared to the displacement that it travels. Okay, we're going to have time squared on our x-axis and our displacement on our y-axis, and the slope of that should turn out to be 1/2 the acceleration of that card. Okay. But because we're dealing with time squared, and because we're dealing with 2 positional values, and because we're dealing with 5 time measurements, calculating the percent error is a little more complicated. It's a little more involved. And that really is the purpose of this experiment. Not necessarily to calculate the acceleration, but to get an understanding, to get a handle on this idea of percent error. Cool? I hope that helps you with this falling down the incline. All right?